A Rosie math teacher coming at you from my 4th period accelerated grade 7 math class, where right now we are working on textbook page 77, lesson 1-9, scientific notation. Here we go, y'all. Let's start at the top, and I'm going to use the first practice item for homework as a method of helping my class understand scientific notation. When you need to represent a number that is super, super large, you may sometimes want to write it in a shorter form, which is called scientific notation. Here are the rules for scientific notation. You must take a single digit of value. So, for example, in item number 1, they have taken a single digit of value. It is a 1 in this case. It doesn't have to be a 1, but it has to be a single digit. So that means when you're writing a number in scientific notation, it will begin with either 1, 2, 3, 4, 5, 6, 7, 8, or 9. Class, why can't it ever begin with 10? Because it has 2 digits. And we must always begin with how many digits for scientific notation? 1 digit, a single digit. In this case, it is 1. Class, please trace over your 1 and then trace over that decimal. It is always going to begin with 1 decimal and then any additional significant digits. They call it a significant digit when it is a digit that represents a value. Does the number 0 represent a value? No, so it is not considered a significant digit. However, if we had 1.605, you would keep the 0, but you still would not consider it a significant digit. It would be a placeholder 0. Okay, right now, this amount says 1.6 times 10 to the 3rd. Here's another thing about scientific notation. You are always multiplying by values based on a base of 10. So each time your decimal scoops to the right, you are multiplying by another power of what, class? 10. So for example, if I were to do, don't write this, but look up here and listen. If I were to do this, instead of 1.6 times 10 to the 3rd, if I said 1.6 times 10, class, isn't that the same as 1.6 times 10 to the 1st?
Yes.
All right? And in order to multiply any number by 10 instantly, you simply take that decimal and scoop it in one place to the right. Each time you scoop to the right, you are multiplying by one positive value of 10. So for example, 1.6 times 10 to the 1st, in standard form, would be written how? Please say it if you know. If you said 1/6 or you said 16, wave at me. You are absolutely correct. Now let's take it to the next power of 10. If I did 1.6 times 10 to the power of 2, this time, instead of scooping only 1 time to the right, I will scoop how many times, class? 2 times to the right. Please watch what happens. 1, 2. I'm using a different color ink so that you can see. I'm going to place a 0 inside my empty bucket, giving me a value now of 160. How would you read that amount, class? Read it now.
160.
160. Absolutely correct. Are you starting to see the pattern that happens when we're writing a number in scientific notation? So finally, we're going to do the number that they gave you originally. They said 1.6 times 10 to the 3rd power. This time, let me write my 1.6 here so I've got room. And I am going to scoop that decimal. What direction, class? Right. How many spaces? 3. 1, 2, 3. You scoop your decimal. 1, 2, 3. Remind me, what goes inside those empty buckets? Zeros. Giving you a final value of, read my new number, please. 1,600. And if you should choose to enter these answers online, would they want you to place the decimal here, yes or no? No. If that's where it ends, we don't even need to place that decimal. Do I have any questions on how number 1 shall be 1,600? Yes, sir. What is your question?
Why can I not just do 1 plus 6 times 10?
You are doing 1.6 times 10 to the 3rd power. Okay, do you not understand how to do this? This is all I need a question on, if you don't understand how to do it. Okay, guys, I wish we had time for discussing lots of different ways. We don't. We need to stick with, here is a way that works. If you cannot follow the way that works, then I want you to ask a question. All right, number 2. Everybody looking at item number 2. This time we get to practice a negative exponent. What do we remember about negative values? They mean the number is exponentially what? Going down. What's a fancy word for that? Decreasing. Remember, when we're multiplying by a positive exponent of 10, your number is exponentially what? Increasing. So when we multiply by a negative exponent of 10, your number is exponentially decreasing. Therefore, that decimal will now move in what direction? To the left. What symbol in number 2 is causing us to move to the left when we see 1.49 times 10 to the negative 7? What symbol is making you move that decimal to the left? Say it, class. Negative symbol. Great job. And what is that exponent 7 telling you? That it will move to the left how many spaces? 7. Excellent. Please rewrite 1.49. And since we know our decimal is going to scoot to the left and we're going to do it 7 times, don't you agree we want to write 1.49 farther to the right, leaving us space to move that decimal 7 spaces to the left? Everybody do this now on your paper and count. 1, 2, 3, 4, 5, 6, 7. There is my new decimal. I like to put a 0 in front of it as well, just to bring your eyes' attention to it. Fill in every empty bucket with a 0. Now, what do you notice? We were doing 1.49 times 10 to the negative 7. So some kids think that there would be 7 zeros here. But do you recall our first bucket already had a digit of value in it? They call it a significant digit. So how many zeros are in between your decimal and your 1? Say it, class. 6. So 0.6 zeros in a row, your 1, and then 4, 9. My new amount is 0. How many zeros? 1, 2, 3, 4, 5, 6, 1, 4, 9. So now, guys, you are seeing why someone who is a scientist will very quickly prefer to use scientific notation, won't they? It's much simpler than writing it in standard form. I will take questions at the end, not right now. Okay, let's go to item number 3. I want to show everybody how to do item number 3 because there's a little surprise right here. 8.3 capital E to the negative 6. Here's all you need to know about that capital E. It is telling you times a base of 10 to the exponent you see after it. So for example, draw yourself an arrow and relabel this. 8.3 times 10 to the what? Negative 6. Great eye. Are you now understanding? It's just saying this means exponent to a base of 10. Exponent to a base of 10. So 8.3 times 10 to the negative 6. They just wrote it full size, so it might confuse your brain. All right, so if a calculator screen showed you 8.3 capital E negative 6, how could we write this in standard form? Let's begin by copying down 8.3. Now hold on. This is a negative power of 10. Which way will the decimal need to scoot? To the left. If the decimal needs room to scoot to the left, you should write your number toward the right so that you leave yourself with plenty of space. Starting at that decimal, how many scoops am I going to take, class? 6. What direction? Say it again.
Left.
Left. Everybody go 6 to the left. 1, 2, 3, 4, 5, 6. New decimal, 0 in front. What goes in every single empty bucket? 0. Now that you realize it was to the negative 6, but we already counted the first scoop on the 8, how many zeros are in between? 5 zeros. You got it. So your final answer should be 0.5083. Get rid of that little beginning decimal. It is no longer there. Now, if they asked you, how many significant digits do you see in this number? You would say how many? 2, because 2 of them are not zeros. Anything not a 0 is a significant digit. I would like you already know how to do item number 4. I would like you to go to item number 5. You're going to write each number in scientific notation based on the standard form that you see here. Remember the rules of scientific notation. How many digits can come before the decimal? Say it. one single digit. Doesn't have to be a 1, but it cannot be 10 or higher because that would take 2 digits or more. So let's copy the first significant digit right now. Everybody copy the first significant digit right now. And instead of having a comma and the standard form, we're going to rewrite it with that significant digit 2, place a decimal there, and count how many spaces from our new decimal to where the old decimal used to be. I do it in sets of 3. So 3, 6, what? 9. So I can tell that I am going to have to multiply 2 point. Now guys, go ahead and copy through the significant digits. Like I said earlier, 0 will get copied because it still has a significant digit after it. So copy 2.204 times 10 to the, what do you think I am going to count in order to find out how many place values we traveled? I'm going to count the number we counted earlier. Go from this decimal to this decimal. On the count of 3, say the amount to me. 1, 2, 3.
9.
If you said 9, wave at me. You are totally correct. So it is times 10 to the 9th power. Now, how should you know it's to a positive power? Because the scientific notation part, 2 point something, is way smaller, isn't it? The number here, 2,204,000,000, is way larger. I hope this helps. Bye, guys.